All right, explorer, are you ready? I say it's time to leave planet Earth. Let's take a quick spin around the universe and search out some secrets, eh? It's the Fun Kids Science Weekly. My name's Dan, and this week, in the only show that really does reveal what's happening in our galaxy, we'll look at tigers. Have you ever wondered why they are, so striped from nose to their tail? We'll look at the clever science and the survival secrets behind their bold patterns.
Tigers are stripy. It's quite interesting, especially compared to leopards who are spotty and lions who don't have stripes whatsoever. We believe that stripes are there to break up the shape of the tiger.
Also in Battle of the Sciences, we uncover what makes you, you.
And the DNA is basically, they are these letters that make up the code, the genetic code that instruct the proteins to produce a healthy individual.
And for our dangerous Dan, we're finding a centipede that can swim. It's all on the way in a brand new Fun Kids Science Weekly. Let's start with your science in the news. A meteorite that crash-landed in the United States of America is older than planet Earth. Scientists from the University of Georgia have examined a fragment of the rock, and they found that it probably formed 4.5 billion years ago. It's 20 million years older than Earth. Now, people in Georgia, the state where it landed, where it actually smashed into a house, said there was a booming sound as the fireball tore through the skies. Scientists have worked out it was travelling at 1 kilometre per second when it crash-landed straight through a roof. How amazing is it? So, the meteorite is 4.5 billion years old. It's 20 million years older than Earth. When you hear those two numbers back to back, you think, oh, that's no time at all. 20 million years. That's the difference. That's like 100, 1,000 times but longer than humans have been on this planet, I think, if my maths is all right. Right, next story. A study of dinosaur teeth shows that they were very fussy eaters. Liam Norris, who's a paleontologist, has been studying the teeth and has found, by looking at how much calcium in them, that some dinos preferred to eat specific parts of the plant, maybe the soft leaves instead of hard twigs. And this meant some dinos got different nutrients, so grew to different sizes. Talking about more old stuff, how amazing is it that we could look at teeth, tiny fragments of teeth, and we can find out what dinosaurs ate? And our final story this week, one of the world's most stable superstar glaciers is set to disappear. Perito Moreno in Patagonia, which is on the bottom tip of South America, it normally attracts around 700,000 visitors a year, but it's in retreat with the ice shrinking. What does this mean for the rest of our water? We can find out. Professor Neill Gasser is from Aberystwyth University and has been really looking into this. Neil, thank you for joining us. Why is Perito Moreno so special?
Yeah, thanks for having me on. So Perito Moreno Glacier is one of the most stable glaciers in South America, and somewhere like 9 out of 10 of all the glaciers in South America are actually retreating, but Perito Moreno wasn't until recently. And that's because it ends in a lake. It has a carving front where icebergs break off, and it ends in a very shallow part of a lake. And up until now, it's been relatively stable because of that position, but it's forecast now that it will start to change very rapidly in the next few years.
Now, I've seen pictures of this online. I've not been lucky enough to get to Patagonia, but it looks wondrous, like these thick crystals of ice. Just describe it as best you can, and how it has become a glacier, Neil.
Oh, it's a wonderful sight. Absolutely, completely agree. So the glacier is born up in the snowfields, high up in the mountains in Patagonia, where there's huge amounts of snowfall every year. And as that snowfall gets compacted year upon year upon year, it slowly transforms into ice, glacier ice. So what you see at the front of the glacier now was snow several hundred years ago, which has become compacted. And the front of the glacier is incredible. As you said, it's this crystal clear white blue ice, and it crashes down into this turquoise, beautiful turquoise lake where the icebergs are born. And in doing so, it comes right down through forest. There's beech trees, beech forest, right down to the lake level. And it's an incredible sight, which, as you said, draws over 500,000 visitors every year. They come to stand on a viewing platform where we can watch the icebergs break off as part of a UNESCO World Heritage Site and an incredibly popular tourist place.
And where it is, it's some journey to get there too. The problem is, Neil, it's in retreat. What does that mean, and why is it disappearing?
Well, it's retreating because the summers have got warmer. It's very simple. That snowfall that I described has to survive its journey from the snowfields right down to the ice front. And if you have years where there's less snow, or you have years where the summers are particularly warm, that snow can't complete its journey. And over the last 50 or 100 years, there's been increasingly less snow, and there's been much warmer summers. So in effect, it's responding to that. It's being starved of the snowfall that it needs, and it's melting more because of the warm summers.
And it took many, many hundreds of years, even more than that, to be formed. How quickly can something like this go away?
Well, luckily, it won't disappear completely in our lifetimes. What will happen is it'll get smaller. It will begin to retreat, and it will retreat back up into the mountains where the snowfall can continue to accumulate. So if it was going to disappear completely, we'd be looking at probably several hundred years for that to happen. But I think, luckily, it will be a few tens of years. We'll see the changes most rapidly, and then it'll stabilize back up in the mountains over the next few hundred years.
So the problem, it doesn't. We're not just losing something of beauty, but how else might this impact the local area down in Patagonia? Are water levels going to rise? What might happen?
Yeah, I mean, well, one of the biggest implications of glaciers receding around the world is, of course, they store fresh water. And when that fresh water is released by the glacier melt, it goes back into the sea. So probably the biggest single consequence that we will notice will be sea level rise. And that's forecast to be somewhere in the region of 30 to 40 centimetres over the next 50 to 100 years. And of course, that's going to affect people who live in low-lying areas of the world, particularly parts of the UK. It will be London, South East and East Anglia. Is it too late to do anything about this? Well, it's never too late to do anything about it. We can all do what we can to try and combat climate change, particularly listening to podcasts like yours that make us better educated about what's going on, participating in community climate change projects, making small choices in things we do every day, walking, biking, using public transport instead of cars, reducing and reusing our waste, so we recycle paper and plastic, making sure we can save energy by turning off lights and electronics when they're not being used, and basically getting involved in community projects. So planting trees, joining eco clubs, doing local cleanup events, and writing to your MP and people who are in positions of power and asking them to help.
Well, it's been brilliant to learn all about it and get some ideas from you. Professor Neill Gasser, thank you for joining us.
Thank you.
Right, if you have anything sciencey that you want answered on the podcast, make sure you leave it as a voice note for me on the free Fun Kids app. You can do it too at funkidslive.com. That way you can star on the show, and I really know what you're thinking. I'll get a genius to sort it out as well. First question this week, this is from Maddie, who wants to know, how far does space go? Well, there's a difference in how big space is, Maddie, and what we can see. There is the edge of our observable universe, and that's 46.5 billion light years across in every direction. So imagine a sphere, a circle that's 93 billion light years across, and when we're somewhere in the middle of it for us anyway. But that's the universe that we know is there. The problem is there may be loads more universe, but light hasn't travelled to us yet. Current models suggest space could be infinite, stretches on forever without looping back. It might be what they call finite but unbounded. But like a sphere, like a circle, you could travel forever without hitting an edge. Now, some experts think that it's always growing, but it folds in on itself. It kind of wraps itself round. I guess imagine the universe like this. you're standing on a road in a very foggy night. You can only see so far in the mist. That's the observable universe. But as you move forward, as light grows more, it becomes clearer. We learn that there is more out there. That's like the universe that we discover. So the answer to your question, in the short way, Maddie, is that, well, what we know is that there's about 4.6 billion light years of universe in every direction. Thank you for the question, Maddie. Let's get on another one then. This is from Naira. What do you have, Naira?
Why do tigers have so many stripes?
Naira, thank you so much for your question. Why do tigers have so many stripes? Well, we can find out. We're chatting to Dr László Tálas, a zoologist from the University of Bristol. László, thank you so much for being there. Why do tigers have so many stripes?
Yeah, tigers are stripy. It's quite interesting, especially compared to leopards who are spotty and lions who don't have stripes whatsoever. We believe that stripes are there to break up the shape of the tiger. So tigers live in densely vegetated areas, jungles, dense forests, where breaking up your shape could help to hide from your prey, such as deer. Tigers love to hunt deer and wild boar. That's their main type of prey. So there is this concept in biology called disruptive coloration. It's when you have highly contrasting marks on your body, for example, stripes, that help to break up the shape of your outline. So as a deer, you can learn that, tigers, they're the big cats, they sort of have a typical shape. And they can have this sort of search image, so-called search image in their brains, and they would be looking for this, obviously scared that the tiger might jump on them. But if this shape is messed with, basically, as the tiger is doing with the stripes, then it's no longer easily recognizable. And that's how we believe disruptive coloration works.
So it's not only to maybe blend in with the different plant life and colours around you. It's actually to confuse the prey. It's to throw them off what they are expecting to see.
Yeah, that's correct. I mean, I don't know how stripy the background is, so that would be something to facilitate blending into the background. There's another idea we call background matching, when you just become part of your background. I don't know how many black stripes are out there in the tiger's background. I mean, the tiger could be hiding in grass, and if you imagine the sort of shade between the grass stalks, that might appear dark. That could look like, tiger stripes, I guess. I think when it comes to blending in, it's actually the other color of the tiger that might have a more significant role, which is the orange-brown. It looks a little bit confusing to us that why would an animal that is really interested in hiding, and it's typically hiding in green, lush environments, appear orange. And it's actually to do what we believe. It's to do with the visual system of the prey, the color perception of the prey. So how deer see colors. Deer turns out to be that they are red-green colorblind. They can't tell the difference between green and red. This is the typical mammalian condition. Us humans have quite special color vision amongst mammals. So for a deer, the orange of the tiger actually looks the same color as the green background. And that might help for the tiger to blend in. Wow. So it might be that actually the tiger is using a sort of dual strategy here, right? So it chooses the right color, which is orange. Tigers can't be green. Mammalian hair cannot be green. There are chemical reasons for that. But it can be orange. So it doesn't really matter because orange appears as green for the deer anyway. So it chooses the right color. And then what is most contrasting with that orange-brown? Well, it's probably black. So that's why the stripes are black, because this disruptive effect, breaking up your boundaries, really works if your colors are highly contrasting, if they are very different from each other.
Well, so much to learn there. Naira, brilliant question that helped us explore even colour blindness in deer and a lot of mammals, they can't make green fur. It's been a real joy. Dr. László Tálas, for unpacking that with you. Thank you for joining us. Naira, thank you for your question. If you have anything sciencey that you want answered on the podcast, make sure you leave it as a voice note for me. You can do that on the free Fun Kids app and at funkidslive.com. In just a week or so, I'm back on the road for another Fun Kids Science Weekly live show. We're playing all around the UK, got things coming up in Swindon, in London, we're out into Essex as well, and I would love to see you there if you're in the UK. We're doing live science on stage, the best experiments you've ever seen, more fun than you've ever had science before. Genius guests, deadly beasts, and stuff from outer space. You can get your hands on a meteorite. It's all happening just a week or so more until our next Fun Kids Science Weekly live show. If you want to find out where I'm playing near you and get your ticket, grab a grown-up and head to funkidslive.com/tour. For this week's Dangerous Dan, where we look at the weirdest, most unique and odd things in the universe, we're headed into the water around Asia to find a centipede. Yeah, you heard that right, a centipede, but a centipede that swims. Have you ever heard of a centipede in the water before? Well, there is just this one. It's the Scolopendra cataracta. It's the first known semi-aquatic centipede. That means it can hunt in water too, so it massively improves its chances of getting food because it can go somewhere other centipedes don't. Now, it's normally got a greenish black body with long fiery orange legs and an antenna that juts out. This species was first discovered in 2000, so 25 years ago, in Thailand. Now, because of that, it's quite recent, we don't know too much about it. The giant water centipede grows to around 20 centimetres long, not too big, and it can run along the beds of rivers. It weaves through the water, swimming almost like an eel, kind of squashing itself, then dragging it around, swirling like an S through the water. It's got thick pincer-like fangs which deliver a painful bite. It can attack fish and underwater insects too. It's a centipede that's decided, well, I've got these legs, might as well put them to use. Why would I stay on land? Let's go grab some food and go swimming. And that intelligence, that devious geniusness, means the giant water centipede goes straight onto our Dangerous Dan list. And for this week's Battle of the Sciences, where we try to learn the greatest science in the history of the universe, we are looking at what makes you, genetics, DNA, and how we might change them in the future. This is big stuff. We're talking evolutionary genetics with Professor Kok van Oosterhout from the University of East Anglia. Professor, you have 1 minute to tell us why your science is the greatest science around, and that minute starts in 3, 2, 1, go!
Thanks very much, Dan. Hello, my name is Kok van Oosterhout. I'm a professor of conservation genetics or evolutionary genetics. And I think that's the coolest science there is. So let me ask you first something. What do you think is the most rewarding thing that you can do in your job? Maybe it's saving a person's life. Well, yeah, that would be amazing. But what if you could save an entire species from extinction? So that's what we are trying to do with the help of science. So I study birds that are threatened with extinction, like the pink pigeon. The pink pigeon is a really beautiful bird from Mauritius, and it's the cousin of the famous dodo that went extinct. So there are only a few hundred pink pigeons left, and they're struggling because their DNA has too many harmful mutations. These are kind of spelling mistakes in an instruction book on how to build a healthy pigeon. So what we are trying to study now is how to best use genomic engineering, which is a bit like DNA spell checker. And we aim to use this to fix those mutations in the DNA and help the birds stay healthy and strong.
Wow, I mean, it does sound very, very cool. And just the amount, it reminds us of what science can do now. Just on like a big scale, Professor, it's obviously never nice when a creature goes extinct. What what would happen to the local ecosystem if something like the pink pigeon were to go extinct? So are we just saving it because we can, or does it have big impacts in the local area?
That's a good question then. So there are some species that are called keystone species. And if those disappear, then the whole ecosystem can collapse. So some species are really fundamental for the kind of the health and the well-being of the whole ecosystem. All the trees, all the nature, all the insects, and that is kind of in harmony normally. And if you take out all these kind of species, some species, then the whole thing can collapse. So yeah, for some species, it is really important, not just for the species itself, which of course has a real value too, but also for the whole ecosystem they're living in.
I know that you would have studied how to do this for years and years and years and years. We don't have that time. How do you actually do it? How are you changing the DNA of a creature? Is it done like on a games console? Am I looking at my computer screen? When I've changed the DNA as well, how am I getting it back into the future animal?
Yeah, so it's a long process. So first of all, you need to know what is really wrong. So basically what we do is we use DNA sequencers to sequence the DNA. And the DNA is basically, they are these letters that make up the code, the genetic code that instruct the proteins to produce a healthy individual. Now, sometimes these letters can get mutated. And then the protein doesn't really recognize what it needs to do, and it makes faults. So that is then basically a bad mutation that we try to avoid. Now, what we can do is we can try to read this code, and we can then say, okay, if we now would try to make this protein basically reading this code, what would it actually produce? And sometimes we see, well, actually, this is not a good protein. This doesn't do the job it's supposed to do. So, and then we can say, okay, now let's go back to, for example, museum samples or samples in the Natural History Museum or in zoos or in biobanks. And we can then see, do these individuals still possess the DNA that is intact, that has that good letter in its DNA? And if we find that, then we can bring that back into the genome through what's called genome engineering. And that's a whole process by itself, which actually goes from an egg really back to the embryo, where you introduce a little bit of DNA, and that embryo grows then with that new bit of DNA to a healthier individual.
Now, you're doing it with birds, bringing back creatures which might be keystones for the local ecosystem, as you say. How worried are you that the technology that you're using in the future might be used by people who are doing it not as harmlessly as bringing back birds and maybe kind of creating humans that just live forever and are going to take over everything?
Yeah, no, that's true. Science can be used for good and for bad, and that is with almost anything. You can use a scalpel to do a surgery, and you can use a scalpel to stab somebody. Are scalpels bad? Well, it's how you use it. How you use the instrument, how you use the technology, that needs to be really regulated. And that is something that we are really serious and very conscientious about. We really think about how can we use this best, and that there is oversight, that other people can also say, are we doing the right thing or not?
We always finish, Professor, with the same question. No matter what science we're talking about, if I were to throw you forward years and years and years towards the end of your degree, your career in evolutionary genetics, what's the one question that you would like to answer? What's the one discovery that you're desperate to make?
Well, I think what I would really love to know then is, how can we stop this extinction vortex that happens? A lot of species are going extinct. How can we really stop this? And what can we do to make basically the ecosystems healthy again? That is a lot of different sciences together, and we're doing a really good job trying to get all this thing together. But it also depends on politicians and people like ourselves actually to do the right thing, and that makes basically the world just a better place.
Wow, well, this is one of the most amazingly futuristic sciences we've ever spoken about, evolutionary genetics. Professor von Oosterhout, thanks for joining us. In Science in the News earlier, we heard all about a glacier over in Patagonia that was changing so quickly. Well, we can find out more about water and where it comes from now. We're catching up with our favourite water-loving geniuses, the aquanauts. And here, in this episode of their series, the team are discovering that only 3% of the Earth's water is fresh water. Most of that is in glaciers and ice sheets. So scientists need to look at different and new ways to collect every drop that falls from the sky. How do they do that?
Aquanauts, engineering our water future.
Only 3% of the Earth's water is fresh water, and most of that is in glaciers and ice sheets. So there's not a huge amount of water to meet our growing everyday needs. Scientists and engineers are therefore looking at new and different ways to collect every drop that falls from the sky and also create fresh water from our oceans.
Hi, I'm Arno. I'm with the Aquanauts. We're wild about water and how to make sure there's enough for everyone who needs it, now and in years to come.
Activate Aquanauts.
As you know, we all need water, and lots of it. So, where might we get more? Well, there's one source that comes to us, even when we'd rather it didn't. Over to you, Ravi. Hope you bought your umbrella.
Thanks, Arno. Yep, gonna need it as we're talking about rain. An easy way to create more water to use where we live, study and work is called rainwater harvesting. After all, it rains on average around 160 days every year in the UK. Rainwater harvesting ranges from using simple barrels in our gardens to more elaborate designs with tanks, purification systems and pumps. It could be a cost-effective way to help reduce water scarcity. Obviously, as rainwater isn't purified, we shouldn't use it to drink or cook food, but it's ace for watering the garden, washing things like our bikes and clothes, and even flushing the loo. Harvesting rainwater is also great as it helps stop surface water collecting. It can also help reduce the risk of flooding by limiting water in our sewer systems.
As well as rainwater, where else might we find alternative sources of water? Ephra's on the scene.
Around half our drinking water comes from groundwater. That's water held underground in the soil or in pores in rock. But there's another massive source of water, which you might think is a much more obvious source, and that's our seas and oceans. After all, they cover 70% of the Earth's surface, which is great news. However, and it's a big but, all the water they contain is way too salty. Whilst a little salt is yummy on food, if you've ever swallowed seawater by mistake, you'll know how horrible it tastes. So, with so much salt water around, is there anything we can do? The good news is, we can take the salt out and turn seawater into safe fresh water. This is known as desalination.
Aquafact.
Desalination isn't a modern concept. Way back in ancient Greece, Aristotle observed that evaporated seawater would turn into fresh water. And for many years, sailors used basic desalination to obtain fresh water, simply by boiling seawater and condensing the steam.
Now, whilst there's a bunch of ways to desalinate seawater, the two primary methods are distillation, where seawater is evaporated using the sun's heat and the condensation is collected as fresh water, and by a clever process called reverse osmosis, which forces seawater through very fine membranes, incredibly thin sheets, that catch the larger salt molecules but let smaller water ones through.
Thanks, Ephra. To find out more, we've come to the Thames Gateway Water Treatment Works, not far from where the River Thames meets the sea. Like the majority of desalination plants, they use reverse osmosis. Although quite complicated, it's currently the most widely used method, as it's efficient and uses less energy. Here at Thames Gateway, 85% of the water they take from the Thames is turned into drinking water. Before it arrives at our taps, it's purified to make it safe to drink, and minerals are added to enhance its taste. So, why do we bother trying to collect rainwater and recycled used water if we can just get it from the sea. Back to you, Ravi, for the pros.
Desalination is great because there's loads of seawater around, and it can be crucial in arid areas where freshwater resources are scarce, like the Middle East. It's also useful when you need to provide clean drinking water in areas affected by natural disasters and where conventional water supply systems are damaged or contaminated. Ephra, you're up with the cons.
The process of desalination and purification can be expensive and uses a lot of energy. It also creates wastewater that contains high levels of salt and pollutants that needs to be disposed of safely so it doesn't hurt marine life, and that means more cost.
The good news is that desalination can be more effective and sustainable with new technologies like better membranes to capture bacteria and renewable energy.
Aquafact.
Thames Gateway can supply 150 million litres of water per day. That's enough to meet the needs of 1 million people.
Desalination is certainly a key way to help people across the world get their water. There's currently over 16,000 desalination plants across the world. The first big adopter was Australia. Other big users are Saudi Arabia and the United Arab Emirates, both of which are desert countries and highly dependent on this process.
It's great that we can turn salty water into drinking water, but we must still be careful not to waste it. And you can help by becoming an aquanaut and doing some simple things, like having a quick shower instead of a bath. Or maybe think about a career in water technology.
Water workers.
There's a wide range of jobs across the water sector, and today's water worker is...
Chemical engineers. As well as being key in desalination, purifying water and cleaning up wastewater, they need a knowledge of the materials in it and their chemical composition, and how they react with each other and the environment. Chemical engineers use their knowledge to design efficient and safe filtration systems and processes.
Cool. Now stick with us. We're going to be helping you understand the challenges ahead and discover some of the cool engineering and careers that are helping solve the issues. We're also going to find out how we can all make a difference, with more tips on how you can become an aquanaut and help engineer our water future. See you again next time when we explore what happens when you flush the loo. Aquanauts, created with support from the Royal Academy of Engineering and Cardiff University. If you'd like to find out more about engineering our water future, visit funkidslive.com/water.
You can hear more from the Aquanauts wherever you're listening to this podcast. We've got brilliant episodes from their series there on the free Fun Kids app and at funkidslive.com too, where you've got so many genius podcast series from us. They're on Google, Apple, Spotify. Now you can ask me a question on the Fun Kids app and at funkidslive.com. Use the big red record button on both of those. You can get your ticket to a live show. Head to funkidslive.com/tour. And Fun Kids, we are a children's radio station from the UK. Listen all over the country on our app, on the website, and if you've got a smart speaker too, wake it up, ask it to play Fun Kids.